You're listening to the Common Descent Podcast.
Hello, David.
Hello, Will.
And hello, listeners. Welcome to episode 246 of the Common Descent Podcast. This episode, in honor of Croc Month, we will be discussing Gharials.
This is exciting. It's so fun to get to zoom in on in this case, a very specific group
Yes.
of critters.
This is a very niche corner of the at least modern times wise, of our crocodilians we have. We're going to talk about the two modern species of gharial and their much more diverse fossil cousins.
Yeah. Talk about what's going on with those weird snouts.
Yes, we're going to get to discuss the unique features and complications of their slender snouts. We are discussing this topic in honor of Croc Month, and because it was requested by me, because no one else requested Gharials, because you've all let me down personally.
The listeners, you really, I'm so sorry, listeners, you really dropped the ball on this one.
It just, come on, how could you not? Look at their very weird face, and how could you not request that?
Yeah, I've been consoling Will all month long. Just pats on the back, boops on the snoot. It's funny because we've gotten a ton of requests for crocs and croc cousins and different groups of crocs. Gharials specifically hadn't gotten a specific request.
Yeah. So I decided it was high time this Croc Month this year we needed to talk about these just absolute weirdos.
So thank you, Will, for submitting this request.
Absolutely.
We really appreciate it. Listeners, if you want to submit your own requests, you can do so through the topic request form on the website.
Before we get into all of that, some quick announcements. As always, we have a Patreon. The support from our patrons helps us run this podcast in almost its entirety and lets us do all the cool things we get to do, go on trips and do all those cool things. And if you sign up, you get extra goodies, extra content from us, live streams, bonus gifts, and at certain levels, shout outs. So here we would like to thank some of our newest patrons, Cirque, Nancy, and Joseph.
Thank you so much for your incredible support to all of our new patrons and all of our previously existing patrons, and to all of our future patrons. Yes. Listeners, if you would like to support us financially through the Patreon and get access to some of the extra special bonus goodies on there, you can follow the link in the episode description, and we look forward to seeing those of you who can.
And as we have announced on previous episodes, now's a great time to sign up because we are in Croc and Snake Month. So the Croc and Snake tier is open. And if you sign up in this tier during these months, your contributions will be added and used to make donations to some croc and snake conservation efforts that we like to do during this time of year.
Yeah, this year we are donating, as usual, to the Crocodile Research Coalition and to Save the Snakes. And our third this year is the Natural Resource Defense Council, which provides legal support and the like for environmental issues for protecting wildlife and natural habitats. So June and July, you can support us and support wildlife and scaly critters at the same time. It's a bundled deal.
Yeah, so check that out. Check those links out if you want to know more about those organizations.
Yeah. Also, if you head over to the Discord, the Croc Chat channel, exclusive to Croc Month, is open. And by the time this episode is coming out, we have already released on World Croc Day a bonus Croc-themed episode where our friend Maddie joined us to talk about her fossil alligator research.
Yes, you can also see our Croc live stream that we did on YouTube. Yeah. That's up there, where we just talked about recent Croc news and random Croc topics for a chunk of time. So plenty of Croc content for your crocky needs.
Yes. Also, that live stream, we were joined by special guest Nora from Leave It to Us, our sister podcast. If you haven't already been listening to Leave It to Us, check it out. It is a separate podcast on a separate feed with their own Patreon and everything. That podcast is Nora and our favorite paleobotanist, Dr. Ali Baumgartner, going off about all sorts of cool plant stuff. So go listen to it. It's delightful. It's a ton of fun.
Absolutely. And then the last bit of news we have is that one of the ways you can also get in contact with us and interact with us if you would like is our mailing address. We have a physical mailing address. You can find it on our website, so check out the link for that. We got some recent mail. We got a couple of postcards, one from Anthony, which was from the John Day fossil beds with a very cool picture on it. Another from Tammy about their visit to the fossil Pokemon exhibit at the Field Museum.
Yeah.
And then we got a letter and some art from Tibble. So thank you all for the lovely letters and mail.
Yeah, thank you. We always appreciate hearing from our listeners. We love what people sharing their experiences that they're having with us or their thoughts about the podcast. And we are, of course, very envious of the super cool places that our listeners get to go visit.
Yes, it's nice. And like Tammy talked about getting to share facts, fossil facts at the exhibit with their friends and family that they learned from the podcast. So like that's very cool.
Getting postcards from our listeners off doing cool things does make me feel a little bit like a grandparent.
Mm-hmm.
Where it's like,
Mm-hmm.
oh, look at what the kids are up to, just out about in the world.
Yeah, no, it's so delightful. So thank you, everyone. And with that, we can wrap up the announcements and move on to our first section of the episode, which is the news. Every episode, we like to gather up some recent scientific news and research to keep us all up to date on what's going on in the world of paleontology and evolutionary sciences and the like. David, what's the first news of the day?
Well, since this episode is focused so much on slender things in the water, my first news is about hagfish.
Oh, okay, yeah. A bit less toothy than our
A bit
current
less
topics,
toothy, but slender.
I like it. Yes,
slender and aquatic, and relevant to this research, not very good at seeing.
Oh, okay.
This is research published in Biology Letters by Victoria McCoy et al., and we will link in the blog post to a press release on phys.org from Ingrid Fedeli. Hagfish are a group of modern day fish. They're around today. They are mostly cartilaginous, so they're not very bony, and they are jawless. Hagfish and lampreys are our two major lineages still around today of jawless fish. They do not have proper opening and closing jaws like we think of basically all other vertebrates. Hagfish tend to live, they're aquatic. They tend to live in deeper ocean waters where they live out in marine habitats, and they have very small, not very functional eyes. Hagfish eyes tend to be small in size. They tend to lack the pigments that vertebrate eyes typically have that help to interact with light. They lack the complex retina in the back of the eye. They don't have a lens. And they are typically covered in a thin layer of skin.
That's what I thought. I thought I remembered that bit, which has always been the most insane aspect.
Yes. So we talked about this a bunch in our caves episode 112. Similar to some cave fish and other animals like that, the eyes are smaller, reduced in structure, and covered by they did make this point in the paper, a thin layer of skin. The layer of skin over it probably does not impair their vision very much because it's such a thin layer of skin. But even below that, their eyes are just missing most of the pieces that you need for an eye to work properly.
Yeah, I was going to make a joke of like evolutionarily, this is a permanent blink, but that's not actually accurate. These are not as thick as eyelids. This is a thin covering.
Now, in the past, it had been hypothesized by some researchers that because hagfish are such an early branch of the vertebrate family tree, it was hypothesized that maybe these eyes represent an early stage of vertebrate eye evolution. Right? This is one step along the path to the complex eyes that we understand in so many vertebrates. But over time, fossils and genetic evidence have demonstrated pretty clearly that hagfish eyes used to be complex vertebrate eyes, and they have become reduced over time.
Mm-hmm. Mm-hmm.
But exactly how and when and why that reduction happened is not totally understood. One of the sort of common ideas that makes a lot of sense is these are fish that live in deeper water, and deeper water tends to be darker, so maybe the reduction of their eyes coincides with them just moving out into deeper, darker places, similar to what we see in caves. But we don't know because we don't have a lot of evidence to show us the timing of this transition. This study looks at fossil hagfish at varying places on the hagfish family tree to see if we can put together a picture of their eye reduction.
Cool.
This research focuses on 3 hagfish species, all of which are found at Mason Creek in Illinois. Mason Creek was episode 110. Here on the podcast, Mason Creek is a very famous late Carboniferous fossil site just over 300 million years ago, with tons of really well-preserved, soft-bodied organisms. They're preserved in iron concretions. So these chunks of iron break open and there's like a cool thing in there. And it preserves lots of soft tissue, including tons of fish. There's loads of fish at Mason Creek. There's lampreys and hagfish, including tissues and eyeballs and all sorts of soft features. Cool. So here they took a real close look at these hagfish to see what's going on with their eyes. 2 of the 3 species they looked at, Gilpicthus green eye and Squirmarius testai. Squirmarius is such a good genus. Oh my god, for a hagfish, incredible.
That's such a hagfish name.
Squirmarius. Squirmarius will be the name of a hagfish D&D character that I make someday.
It has to be the minion for the big bad. Come, Squirmarius.
Yes.
Tell me what the heroes have been up to.
Both of these species are, based on comparisons with fossils over time, considered to be an early branch of the hagfish family tree. So these branched off very early, probably diverged around the Cambrian Ordovician, early Paleozoic. So this is one of the outermost branches of the hagfish family tree. They have, as we might expect, small eyes. Mm-hmm. There is potential evidence that there was tissue covering those eyes. There's not like a layer of tissue preserved there, but the structure of the tissue around the eyes, the authors think, might suggest that at one point the tissue was covering the eye. But they have a lens in the eye, which we don't see in modern hagfish, and they're lacking some of the pigments, but not all of the pigments. The cylindrical melanosomes of the eye are absent, but the spherical ones are still there.
Okay. All right.
This suggests that this early branch of hagfish had some reduction of the eye, right? They would have had some limitations to their vision, but not entirely. The third species they looked at, Myxinocella soroka, which is closer to true modern hagfish, a later branch of the family tree, also had small eyes, also had possibly skin covering the eye, also had only the spherical melanosomes in the eye, and does not appear to have a lens.
All right.
The lens in the eye, they point out that it's possible the lens just didn't preserve, but the lenses are preserved in the other hagfish species and in other fish at Mason Creek. So in theory, the conditions are right for the lens to preserve, and they didn't find it. And I think they looked at multiple specimens of each of these species. So it looks like this one is lensless, which means its vision would have, they still would have been light sensitive because they've got those pigments in the eye, but the lens focuses an image.
Yes.
This demonstrates both an early on loss of visual capacity, that early in the family tree they started losing it, that First, the group seems to have lost some visual acuity and then later lost the focusing ability. So we see a
Mm-hmm.
stepwise reduction of the eyes. At some point later, we don't know when, modern hagfish lost all those other features that we see that they're missing today. But what's really interesting is that the Mason Creek fossil beds are shoreline habitats.
Yeah.
These are not deep ocean waters, which suggests that the early steps of eye reduction in hagfish happened before they moved into deeper, darker waters. They were losing their vision in their eyes for unrelated reasons and then later moved into deeper water. And maybe that's when the rest of that reduction happened.
Yes.
And indeed, they point out in the paper that among modern hagfish, the amount of eye reduction we see does correlate with how deep their habitat is.
Okay. Yeah.
So it makes sense to think that some of that reduction was related to their move to darker habitats, but clearly not all of it. This is a
Mm-hmm.
process that happened way, way at the beginning of this family tree before they moved into those environments.
Interesting. This is a fun study because not only is it unexpected to find out that it's not as simple as they went into dark and they lost eyesight, there's
Mhm.
something else going on, but it's also a great reminder that just because hagfish and lamprey are our only remaining jawless fish does not mean they are a picture of what jawless fish were like. They are
Yeah.
very particular examples of jawless fish. It's very much like when monotremes with the platypus and the echidnas get pointed at as like, well, that must be what early mammals were like. No, those are two weird versions. Like most early
Yes.
mammals were like a squirrel and like a rat, not these weirdos.
These are the ones that are still around,
Yes.
almost certainly because they were doing something unusual that the other
Yes.
ones weren't doing, and that's why they're not here anymore.
And then on top of all that, they've been evolving the whole time. So, like, yeah, what we have now
Mhm.
is not a snapshot of what things were like. And yet they have features that are distinct. Other animals, other fish had just functioning eyes. They were doing something weird with their eyes.
Yeah. And a reminder that it didn't happen all at once.
Yes.
Piece by
Yes.
piece, they were losing this visual acuity over time, which is what we expect to see. This is the first time from fossil evidence that we can see a bit of the order that those things happen in,
Yeah.
which is so cool.
And it makes me wonder if, like, was it just that they shifted, because hagfish at least are famously scavengers, and
Mhm.
that's one of the main ways that they feed. I don't know if there are ones that are more predatory or not, but I know that mostly they are known for being scavengers. And is it that, well, you don't need to see a carcass from far away, you're just following the scent. And if all
Yeah.
you're doing is following the scent of dead fish, then those eyes really aren't necessary for that.
Yeah, there are tons of fish that don't rely on their eyes very much, that
Mhm.
have poor vision or very limited vision, because, yeah, they've got all sorts of other senses to get around their environment. So it's not particularly out of nowhere for a fish to lose its eyes.
Yeah.
Yeah, you got plenty of senses, you can handle it. But the circumstances of why this group did it, yeah, we don't know. We can for now only speculate.
Cool. Very fun. Well, my first news, I'm taking things to foil your first news. Instead of talking about something that is particularly jawless, going to talk some very jawed animals, particularly
Mm.
large jawed theropods and their itty bitty arms. This is research trying to figure out
Yeah.
what is the pattern of theropods, two legged predatory dinosaurs, reducing the size of their arms. And it seems to be,
Yeah.
as many suspected, due to their big old heads.
Interesting. Did they lose their arms as they moved into deeper marine environments?
Right? Yeah, well, you no longer needed to doggy paddle at the surface.
Right, exactly.
And so
There's no one to
there's
wave
no.
to in the
Yes,
dark of the
exactly.
deep ocean waters. So it's not just I have a big head and tiny arms. It's maybe I have tiny arms because I have such a big head.
Yes, yes.
Mm.
You could not have one without the other. This is research by Charlie Roger Scherer et al. In the Proceedings of the Royal Society B. And the article is by Sarah Hashemi in Smithsonian Magazine. So, forelimb reduction, the reducing in size of the front limbs, the front arms of theropods, is a well known feature. Many of them have notably smaller arms because they are now two-legged animals. So their back legs are their main way of getting around. They have smaller front limbs, but a lot of groups have really small front limbs. The famous example is T-Rex, having itty bitty arms reduced down to just two fingers. And the question of why has been a focus for this group because, yeah, why are your arms so tiny? Is that helping you somehow, or is it just that you don't need big arms anymore? And a very common suggestion is that they are now no longer using their arms to do the jobs they used to. They're using a big, powerful mouth because many of the groups we see with tiny arms have large, powerful jaws and are head focused. Their head is notable.
Yeah, if you need to grab something, you just grab it with your mouth.
Exactly. This study wanted to look at what are the patterns? How does it actually sort out? So they took a approach of looking at forelimb reduction and head robusticity, of how robust their head was, which not only is inferring the size of the head, but jaw strength and bite force.
Yeah.
How overbuilt was your face? They looked at the ratio of these for 85 non-avian theropods, so not birds, but two-legged dinosaurs. And they found a definite trend of, as heads get more robust, as they put, cranial robusticity and gigantism, so big, robust, giant heads.
Big and beefy.
The more bobblehead-like you get, the smaller forelimbs they tend to have. And that this is like a very connected feature.
Interesting. I mean, my bobbleheads have very small arms.
Yes,
so
same.
I see it.
The pattern continues to this day. As one of the authors was quoted, if you're a dinosaur with very strong, put-together skull, chances are you're going to have small forelimbs. And that it doesn't matter how big a dinosaur you are. Medium-sized theropods and giant theropods followed this trend. So it's not about the size of the dinosaur, just the size of the head compared to the rest of the dinosaur.
Yeah.
They found that this pattern evolved at least 5 times in theropods. The 5 groups were Tyrannosaurids, Abelisaurids, Carcharodontosaurids, Ceratosaurids, and the Megalosaurids.
Yeah, that makes sense. Those all are the ones that come to mind.
Those are like 5 of the big name theropod predators that often get talked about. Of those, the Abelisaurids, Carcharodontosaurids, and Tyrannosaurids show the greatest reduction of forelimb to skull size. And T-Rex earned the highest cranial strength score.
Sure.
So T-Rex has the most robust head of any of the dinosaurs they looked at, followed by Tyrannotitan, which is another theropod from Argentina 30 million years earlier than T-Rex, but also has an unusually robust head. Based on the patterns they saw, it does seem like the reduction in forelimbs is a response to the increase in skull size. That it's not that you get tiny arms, so you need to get a big face. It's that as skulls get bigger, arms get smaller. And that, it seems to fit the pattern of what we suspected, that likely due to prey capture behavior shifting to using the mouth as your capture mechanism instead of grappling with prey using your arms. And that as the mouth became more of a tool of that, you just don't need to grab them anymore. You just bite.
Yeah.
This could be a response to prey getting bigger, the prey that they're going after getting larger, and that being more suitable for just using big jaws. It might just be that it was a more efficient way, that instead of grappling and wrestling, a big powerful bite is a more efficient mode of capturing prey once you're able to use that. So we didn't see a pattern that we didn't expect, but it did confirm that, yes, the big heads and the tiny arms do seem to be directly evolutionarily connected to each other.
Yeah. I remember hearing some time ago the suggestion, I don't know how much support this suggestion has, the suggestion that the reduction of arm musculature made room for neck musculature
Yeah, yes.
to support the skull. That you're it's a trade-off. If the
Mhm.
neck's going to get bigger and bigger and stronger, you have to reduce like the pecs and the muscles that are moving the arms, so that it might be a direct trade-off that have it, you
Mhm.
like you said earlier, you can't get both. You got to pick
Yes.
one.
Yeah.
I've also seen it suggested, and this one feels a little bit less. That one I like. That one feels, I
Mhm.
don't know, again, I don't know if there's a lot of evidence for that, but I like that suggestion. That's very satisfying. The other suggestion that I have seen is that it helps keep the body balanced.
Yes. I've heard
That
that one as well.
as your head gets big, the bigger your head is, the more likely you are to fall forward because you're front heavy. Reducing the arms might be a way to keep the weight of the front half of the body down.
Yes.
That one seems less of a major concern, at least in my mind, just because there's
Yeah.
so many weight saving and balancing adaptations in these dinosaurs that I don't know that the arms are going to make that much of a difference, but I wouldn't be surprised if that is certainly part of it, that certainly helps to have smaller arms up front.
That's what I was going to say is I absolutely can see that as a factor. I don't know that I'd buy someone telling me that's the main push
Yeah,
because well,
same.
there's definitely got to be examples of other dinosaurs that have notable sizes or even if you're including like neck length for some dinosaurs with more
Oh,
prominent
sure.
arms. But yeah, no, it probably doesn't hurt to keep, make balancing and mobility easier if you only have one big set of appendages. You either have
Yes.
big jaws or big arms, and that probably does make things simpler. But yeah, I love that this does seem to just be it's like when you're making a video game character and you have the slider bars to do your stuff. And
Yes.
I've played ones before where it's like if you slide this bar, it will affect other bars. And like
Yeah.
if you slide the head size for your dinosaur character up, the arm slider is automatically going to go down. You cannot
Yes.
have both of those up. That is against the programming.
Very cool. Well, my second news is kind of sort of related to dinosaurs. I'll mention dinosaurs while talking about this news. This is about what fungi get up to around mass extinction events.
Ooh.
This is research by Rosanna Baker and Arturo Casadevall, published in the journal PNAS. We will link in the blog post to an article in Science Alert by Jess Cockrell. We have talked before. We talked about this a bunch in our fungus episode, episode 200, maybe also episode 202, one of those. This idea that fungi seem to do really well during global ecosystem crises. During a mass extinction, when everything's dying and decomposing, fungi are doing awesome. This idea is supported by what are sometimes called fungal spikes in the fossil record. Basically, you look at your layers of sediment, and in the layer where the mass extinction happens, there's a whole lot more fungal remains than you would expect from other layers. This idea, this kind of fungal spike, has been found all around the world at the Permian mass extinction, at the beginning of the Mesozoic. It's been suggested for the Cretaceous mass extinction, the end of the age of dinosaurs, but a fungal spike has only been definitively identified at the end Cretaceous at one site in New Zealand.
Okay.
Which makes it tough to know, that could have just been that one place, right? That one forest, there were a lot of fungi for some reason.
Yes.
This study presents what appears to be the first evidence of another site that shows an end Cretaceous fungal spike.
Ooh.
Here they find it in the stratigraphic layers, the geologic layers around the Cretaceous Paleogene boundary in the Denver Basin in Colorado, here in North America. This is a play that, this is one of the handful of places around the world where you can see the end Cretaceous boundary. You can see the line in the rock. It's like that's where the Mesozoic ended, right there, full of iridium and asteroid impact chunks. They noted in the layers just above the boundary, around 2 to 10,000 years after the asteroid impact and the extinction, the inciting event of the extinction, there is a sustained fungal increase in the sediments. They specified that what they're considering a fungal spike means that fungal spores make up 50% or more of the total plant and fungus spores in the sediment.
Okay.
That when you're counting spores, more than half of them are fungi, which is a distinct uptick from the layers above and below it. This is fun because this is not only a second site with a fungal spike at the end Cretaceous extinction boundary, it is a second site on the other side of the world.
Yes.
Now it's Colorado and New Zealand, which heavily supports the idea that just like the Permian extinction, this was a global event. This was a thing that happened, if not everywhere on the planet, lots of places on the planet. Fungi were having a field day after the extinction event, which makes a lot of sense because not only is there a lot of death and decomposition, there's also a lot of space freedom. A lot of plants are dying, a lot of animals are dying, a lot of things that eat fungi are dying. And so this is a circumstance where fungi are going to do really well. The researchers also pointed out that it doesn't sound like they identified the spores specifically to, what type of fungus do these come from, but they did note that the anatomy of these spores is leaner than typical fungal spores in these layers, with more melanin, more of that pigmentation, which is often associated with UV protection, and overall more like the spores of fungi we see today that are more cold adapted or adapted to acidic environments.
Oh, okay.
So it wasn't just any fungi that were thriving, it was the ones particularly well adapted to difficult environmental conditions.
Yes.
These were the extreme fungi that were coming out and either adapting or were already adapted to handle these conditions.
That makes a ton of sense.
They also identified an earlier fungal spike around 30,000 to 10,000 years before the Cretaceous end Cretaceous boundary, another uptick of fungal activity, which they note seems to line up pretty well with a cooling period, a period of colder temperatures that have been associated with an early pulse of volcanic activity from the Deccan traps over in Asia.
That's what I would thought.
This is a massive area of volcanic eruptive activity around the end of the Cretaceous, which has left behind a large igneous province in the sedimentary and rock layers that are around today. There's been tons of argument back and forth about how much this volcanic activity contributed to the extinction event. At the very least, it is pretty reasonable to infer that it was stressing environments around the world.
Yes.
By creating changes to the climate, changes especially to local conditions. This seems to suggest and to support this idea that early pulses of volcanic activity were having global effects. If not causing full-on mass extinctions, causing disruptions to ecosystems that were leading to stressed conditions where similar fungi were able to survive and thrive.
Interesting. That's fascinating for a couple reasons, because one, shows us that we can get fungal spikes outside of a mass extinctions. So like if you find a fungal spike, it doesn't necessarily mean you have guaranteed mass extinction, but that you could have had similar conditions, stressed ecosystems of things being thrown a little out of whack. But also this gives us similar support that the stresses from the Deccan traps may have been throwing things off kilter before the asteroid impact, which has been a common thought, that the stage had already been destabilized when the impact happened, and that's why it was so utterly devastating.
Yeah.
Cool. That's a lot of fun. Well, bringing it back to dinosaurs, since we were just talking about their death, this next news is about a new species of dinosaur from Argentina with some unusual features that suggests how it was hunting.
Ooh.
This is research by Matthias Moda et al. In the Journal of Vertebrate Paleontology, and the article is by Anastasia Scott in Discover magazine. This dinosaur is from a group called the Unenlagiids, which are small theropods. So once again, two-legged, predatory. These are paravians, so they're closer to the bird side of things. They are similar to dromaeosaurs in a lot of ways. So your velociraptor and also like troodons. These are known from Gondwanan landmasses, so southern continents, South America, Antarctica, Australia, Madagascar, all places they've been found. They're particularly diverse in northern Patagonia, with at least 7 species discovered there from the later Cretaceous. Southern Patagonia has a much more restricted fossil record, with most elements being isolated and fragmentary, so not as easy to determine who they are. These are from Argentina and Chile. This new specimen is from Argentina, about 70 million years old, and is nice enough to identify as a new species and give us some information about this group from this area. This is Canc australis and is represented by some vertebrae, some backbones, some isolated toe bones, and some teeth. In total, it's estimated that this would probably be an animal that stretched about 8 to 10 feet long. So not tiny, but not a massive dinosaur.
Sure. Small head, big arms.
Yep. This one's exciting because it helps bridge the gap between northern Patagonia and places farther south in like Antarctica. That this is now a new specimen along their range. It has some notable features. It has a sickle claw on the second toe, like the rest of its group, but more similar in its shape to troodontids, which does make it a little different from other members.
Yeah.
They gave the specificities of the toe bones as to what that was, but the toe bones are shaped a little different. The big note is the neck bones, and so that's the part that really are important. The fossils, the fragments of this species were actually discovered back in 2018, but it wasn't identifiable until they found material with neck bones, and that had the differences that allowed it to be identified as a new species in 2024. Their neck bones are highly pneumatized, meaning they have air chambers and spaces in the bone. The particular aspects of these spaces share features with modern birds, but specifically only birds we see that hunt by striking at the water, like herons and stuff.
Oh.
That these suggest they were using their neck in a very particular way for some striking head movement.
Yeah, they were adapted to be able to move that head and the neck quickly up and down or back and forth without
Yes.
hurting themselves.
Exactly. Which could suggest that they were hunting in a similar way to these birds. So they might have been fishing dinosaurs. Striking at fish in the water is the suggestion given. And so they might have been more like a heron than a velociraptor chasing after prey the way we think of with dinosaurs like this typically. It might not have been a pursuit, but a sit and wait predator.
Yeah.
They did find remains of fish in the same deposit. So it does suggest that it was sharing its environment with fish. So likely they could have been part of its diet, but also this hunting method would work for other things, frogs, lizards, maybe even like small turtles and stuff. Like there are other animals that they could be hunting, but some small organisms that they're able to snap up with this head movement probably are what they were hunting.
Yeah. I don't know that I've ever considered a small theropod hunting like a heron.
Right? It's
Which is
very
weird
cool.
because it makes all of the sense. That's
Mhm.
yeah, absolutely you could do that. That's tons of animals today are hunting fish on the shoreline. Herons and other wading birds are extremely common and successful, and a theropod dinosaur is shaped just like that.
Yep.
And then you don't have to chase anything.
Yeah, absolutely. And they do have, when you look up a picture of them, very long, slim faces. So not
Mm.
not beaked like a heron, but they don't have like a short, stout face like Deinonychus or something that has
Yeah.
kind of a more stout snout.
You said that the fossils are vertebrae and feet, right?
And some teeth, but other members of this group,
Okay, cool.
yes, also have that snout. And I found paleo art of other members shown as fishers. So it seems like this idea might not have
Cool.
been new to this species.
Cool.
And with that, we can wrap up the news.
Talking about stuff with long, slender snouts, grabbing fish in the water.
I was going to say, we've been talking a whole bunch about archosaurs with notable jaws that might have been fishers.
Yeah.
Let's keep that trend going.
All month long.
All month long. Let's take a break, and when we come back, we will talk about the modern gharials and what makes them so distinct from the rest of the crocs we have today. I was thinking about it while getting ready for this episode, and if it weren't for like elephants and sloths, this would be our most succinct modern group.
Oh, sure. Most of the time when it's rare that we do an episode focused on just one or a few living species.
Yep.
This is one of those.
This one does win out because not only is it only two species for us to talk about in the modern context, there's not many of them. These are also quite endangered.
Just in sheer number of individuals.
Yeah.
Well, and they're also big.
Yes. Yep.
So they tend to be less numerous than things like, even tree sloths. These are big animals.
The gharials are in the Gavialidae family, and there are two currently in that family. That is the current understanding. We'll get into that in more detail as we go on. The Indian gharial, often just called the gharial, Gavialis gingeticus, is the famous gharial that if you just type in gharial to Google, it's what will come up. The false gharial, or Tomistoma schleglii, also known as the Malayan gharial or the Sunda gharial, is the other species. The less well-known and less famous, but very important when understanding this group.
Yes. So of the two species we have to talk about, one of them's not even a real gharial. It's a false gharial.
And for a long time, it wasn't thought to be.
Yes. I don't know hardly anything about like croc taxonomy. I know the deal with the false gharial. This is a pretty famous one.
The gharial problem, as it is known among the research, which we will be talking about. First, let's meet our two players. The Indian gharial, which, just so everyone knows, they get called different things. Sometimes it'll just be called the gharial or Indian gharial. False gharial get called false gharial or Tomistoma. I will probably be calling them gharial and Tomistoma or Gavialis and Tomistoma, because that's what I reflex to, is Gavialis. I like Gavialis more than gharial, actually, because it's just fun. But Tomistoma is what I will be calling the false gharial throughout this, because it's what I'm used to, and it's what most croc people call it, because it's hard to get confused.
Yes, Tommy to its friends.
Exactly. The gharial, the Indian gharial, is a very unusual croc. Both of these are unique, but this is by far our weirdest modern crocodilian. Famously noted for having that very long, thin snout, which we'll be talking about a whole bunch throughout this whole episode. This elongated snout is what's known as a longirostrine snout, and is the characteristic feature of gharials, modern and past. The Indian gharial also has two other notable weird features. Its eyes are protruded, what's sometimes called telescoped. They poke out from the skull and are notably bulging out from the side. And when you look at the skull, the orbits are telescoped out.
Yeah.
And then males have a display structure on the tip of the snout called the gara, because it resembles a pot in India called a gara, which is why there are gharials.
Yeah, it's like a big bulbous structure.
Yes, it's a growth off of the snout, off of the nostrils.
Yes.
And we'll talk more about that. But it is one of the things that stands them out because they're the only crocodilian that has a sexually distinct display structure.
Yeah. Other crocs, there's sexual dimorphism in their size and in their behavior, but they otherwise, like, they strike the same profile.
Exactly. Like a male and a female of the same size, you really can't tell apart without looking at the plumbing. Like
Right.
there's no major indicator unless one is doing some sort of display or like building a nest
Right, we're
that would
laying eggs.
give yeah, give it away as being male or female. Gharials also have sexual dimorphism in their size, but the males, a full-grown male, has the gara as well, which
Yeah.
is
It,
noteworthy.
it is very fun to reflect on the fact that there are tons of infographics and lectures and stuff out there on how to tell an alligator from a crocodile. There's
Hmm.
lots of info out there about the question, how do you tell an alligator from a caiman? No one needs to ask how to tell if it's a gharial.
No.
They are really so distinct from the rest of crocs.
Yeah, they stand out. They have many, many tiny, very pointed teeth that are all equal in size, which is another thing that's weird. They don't have that
Yeah.
changing in size throughout the mouth that you see in crocs and gators. They are also one of the largest living crocodilians. Males can reach 16 to 20 feet, so 5 to 6 meters. They are, on average, one of the larger species of crocodilian on our planet,
Hmm.
which, as you noted, means that they are less numerous than they might be if they were smaller, but they are also less numerous because their population is not doing well and is in a very small region. They're now only found in fragmented populations in Nepal and northern India, typically found in flowing rivers and deep ponds and pools with sandy banks, which is where they make their nests. They are one of the most critically endangered crocodilian species today. They survive in only about 5% of their former range. They used to be found much more widely across India, Pakistan, Nepal, Myanmar, Bangladesh, Bhutan. Used to be much more numerous. Their breeding population is estimated at less than 1,000, which is about 1/20th of what their historical population was at. So they were never like covering a continent, but
Yeah.
they used to be doing much better, and now they are doing quite poorly. Gharials are famously mostly fish eaters, is one of the things that we'll be talking about quite often in this episode. This is aided by their thin snout and interlocking, very sharp teeth, which makes it good for grabbing fast, slippery prey in the water. As like others, the young tend to eat things like insects and then shift up to fish and things like that as they get bigger. Though very large individuals have been noted eating other prey, other things around the water. Their diet of fish also makes sense because they are arguably the most aquatic modern crocodilian.
Hmm.
They spend basically all of their time in the water. They only leave to bask and nest, which is similar to other crocodilians. But, and this is one of those where this isn't something we can confirm easily because we can't ask them to do what we need them to do. But based off of anecdotal and just observational evidence of large adult gharials, it seems like they refuse to or maybe can't stand up out of the water once they leave.
Yeah, they are belly dragging.
They are belly crawling.
Yeah, other croc species will like go for a stroll. You know, they'll
Yes.
cross the street or whatnot and they'll lift themselves up off the ground to do it. Gharials are salamander mode the whole
Yeah.
time.
They are always, and they're typically always going to have belly in contact with the ground and just be
Hmm.
sliding. They cannot no longer, it seems, go into the crocodilian high walk where they actually stand up and walk with only their legs. This is because proportionately they have fairly weak leg muscles and smaller limbs to their body size than
Hmm.
a lot of other crocodilians. So yeah, they are extremely good in the water and extremely not good on land. Tomistoma, the false gharial, very similar in many regards. Long, thin snout, very sharp teeth. They live in pocket populations throughout Indonesia and Malaysia. They're less endangered, but they are still considered threatened, and their populations are very small. So they're over a wider
Hmm.
area, but they are in very small pockets. So they don't have big, robust communities. They're a bit smaller than the Indian gharial. Not small, they still get up to like 16 feet for a male, but just not going to reach that 20. But they differ in a number of ways. Their face looks quite distinct from an Indian gharial. They have that long snout, but they don't have the protruding eyes, and there is more of a tapering from the head to the snout. With a Indian gharial, the face tapers in almost at right angles to get to that narrowed
Mhm.
snout. Like, it's extreme how quickly the snout gets slender. Tomistoma, it's more tapered, and it looks kind of more like a normal croc back of the head.
I was gonna say, Tomistoma, the false gharial, does kind of look like a weird shaped crocodile. Like,
Yes.
because like crocs have that V, right? The pizza slice shaped
Mhm.
skull. The eyes are very similar. This is one where you can say, all right, it looks like you just kind of stretched out a crocodile's snout
Yeah.
or squeezed it a little bit. Like it's a little bit off, but the general shape is there. The Indian gharial looks like a different type of creature.
Yeah, it looks like a muppet.
The facial structure is radically different.
So they do have some distinctions, and behaviorally they are a bit distinct. The Tomistoma is also known mainly as a fish eater, but has been observed and is known to take a much wider variety of prey animals,
Mm,
including things up to small to medium-sized mammals, things like monkeys and pigs, and there are
yeah,
documented cases of attacks on humans and deaths due to Tomistoma.
because it's a weird croc, but it's still a croc.
Yeah.
In its heart, it's got the heart of a
Yes.
crocodile.
While the Indian gharial, there is basically no documented aggression between them and humans other than humans hunting the gharial.
Sure.
There have been attacks, I believe, but I don't think there's any documented deaths due to the Indian. Maybe one on total record
Yeah.
of
Well, and
someone
they're
dying due to an Indian gharial.
all crocs will be defensive, right? Like you can
Mhm.
have physical conflict that shows up between a person and a wild animal, but most crocs are pretty happy to eat a person if they get the
Yes.
opportunity to do it. The Indian gharials seem to be the one major exception
Yeah.
that they are not there. There's no taste for human in there.
Yeah.
If there is a conflict, it's going to be a defensive thing exclusively or territorial or something.
Yeah, we are exceedingly far outside their prey size category and environment. They are not shoreline ambushers, they are
Yes.
aquatic hunters.
And we are bad fish.
We are bad fish. Lucky for us. So, in this specific case, both gharials do share another weird note that I found mentioned a couple times. They're unusually quiet for crocodilians.
Huh.
Yeah, crocodilians famously are quite noisy reptiles. Alligators bellowing, crocodiles roaring. Most species will hiss when they are threatened or annoyed.
Yeah, the babies chirp for their
Yep,
parents.
yep. They'll also do non-vocal sound making of head slapping and jaw clapping and things like that, bubbling that make display noises usually in the water. Both will do some of these, bubbling and things like that. Both are known to hiss. The babies do still chirp, but they don't seem to have any sort of bellow. They don't seem to have much
Hmm.
big loud sounds that they're typically doing. The Indian gharial may not be able to produce infrasound, or at least doesn't seem to, which is part of the bellowing that alligators do, is that below our hearing infrasound that travels much farther than the audible sound we can hear.
Interesting.
They are not silent though. The Indian gharial does have a specific noise it can make, and it seems to be able to make it because of the gara.
Is the noise Gharial, Gharial.
Gharial, Gharial. This is something that's been discovered fairly recently. This is something we didn't know for a very long time. The Gara has been a mystery for Gharials for most of their history. We didn't know why they had it or what it was doing. We assumed it was some sort of display structure, but we didn't know if it was purely visual or if it had some other function. To give a bit more information about what this structure is, it is a soft tissue growth on the end of the snout over the openings to the nostrils. It grows from in front of it and arches back over the nostrils. It's made out of cartilage and soft tissue. It's bulbous. On
Mhm.
average, for a big male, it averages 10 centimeters by 10 centimeters by 10 centimeters. So it's kind of cubic in its overall shape, but it's got kind of this lean to it. It leans back over the snout. It also evidently develops pretty quick within like 14 to 18 months. So, like
Ooh.
within a year or year and a half, a big adult male will develop the Gara. So, it doesn't grow throughout life, it grows when they reach maturity.
Yeah, it kind of looks like you'll see some somewhat similar structures on some birds
Yeah.
or even like big mammals. Some will have this. I'm thinking of like that thing that camels do where
Mhm.
they inflate that pouch from their mouth. This sort
Yes.
of big or like a proboscis monkey where they've got the big
Mhm.
it is sort of a big nose or face bulb. It isn't a hard structure like a bony structure. It is similar to what we see in a lot of these other groups of animals.
Yes, and is unique to the gharial, though not just to our modern gharial. There is an impression on the snout, on the nasal bone,
Ooh,
that indicates the presence of a gara on a mature male, and we do find evidence of that in some fossil gharials.
that's cool.
Now, it doesn't ensure they had a full gara, but that they might have had some sort of display structure up there and something similar to our modern gara. Also, as I say it over and over again, I just keep hearing myself saying the character from Naruto. And if someone doesn't do it or hasn't done art of Gara as a Gharial, then I don't know what we're doing with the internet. I don't know what the point of it is.
This is your chance. You better quick before Will checks.
The function of the Gara had been debated and puzzled over for quite some time. It was thought to maybe be a resonating chamber,
Hmm.
but it's not connected to the air passages at all. There was a suggestion early on that maybe it was a breathing apparatus and would inflate and help them breathe while underwater, which is very, very, very much not true.
Okay.
Other than visual display, we didn't have an answer. Fairly recently, it was noted that gharials have a specific noise they're able to make while in the water. So this is an underwater noise and display, and it's called a pop. When they rapidly close their jaws, the tip claps together at such speed and force because these nice slender jaws make for very quick closings that it seems they cause cavitation at the tip, basically forming bubbles out of vacuum because they've clapped together so quickly. This is the same thing that happens with pistol shrimp and mantis shrimp when they are using their claws to quickly move and causing the water to evaporate at the spot of contact. And that seems to produce a very loud popping sound that is audible under and above water. And they
Ooh.
noted that when they did it, other gharials seemed to respond to it, and that they did it in different situations, and that this seems to be the gharial's own personal communication display, and it seems to be facilitated by the Gara. Now, how the Gara specifically is causing the pop, we still don't know. We have not
Hmm.
figured out the physics of the pop yet, but it's only seemed to be produced by mature males with a Gara. So, most likely a connection.
Interesting. I wonder if the shape of it moves the water in a certain way or it splits the water in a certain way. I'm thinking of the same way that ships and their
Mhm.
hydrodynamics or planes and their aerodynamics, certain shapes and not always in an intuitive way move the air or water around a structure in the way that is optimal for what you want. And I
Yeah.
wouldn't be surprised if this is a situation where, like, yeah, that bulbous round shape for some reason pushes the water or captures the water and creates just the right situation for this big cavitation sound.
It could also maybe be adding enough weight to the tip or something to get the speed you need to create
Yeah.
that. Yeah, the physics, I'm sure, are going to be fascinating once we work them out. But so far, we can tell this isn't a sound they're making with their voice box, with their larynx. It is some sound coming from the tip of the snout closing together.
That's so cool.
The other famous thing about the Gharials, as we mentioned up front, is they've been a problem for taxonomy for decades,
Yeah.
centuries, in fact. Like since the 1800s, people have been puzzling over where they should go. This is caused because of a couple of main issues. One, their weird anatomy. They are very,
Yes.
very extreme looking crocodilians for the modern times, at least. And that often makes comparison tricky because when you're so different, it's hard to find which similarities we should trust and which differences are important. They're also very similar to each other, which could be because they're closely related or convergence, especially since the slender snout has been thought to be a key indicator for fish eating. So maybe they're just living the same way. And then with the addition of molecular data, DNA analysis, the morphological, so looking at their bodies, and the DNA evidence consistently disagreed as to where they should be placed within relation to each other and generally on the crocodilian tree.
Yes, this is something that we might refer to as the turtle problem.
Yes. It's a famous example, and basically any paper, if you just go look up a random paper about the gharials, it will probably mention this at some point in the introduction, or at some point mention what a thorn they've been in the sides of crocodilian taxonomists. So the issue is, when we look at the different data, looking at their skeleton and the fossil record, the Indian gharial places outside of other crocodilians, of our modern crocodilians, that it should be off on its own, separate from crocs and gators, which group more closely together. And then the false gharial, Tomistoma, groups near or just within crocodiles, crocodilus, and close to crocodilianae, which intuitively makes sense when you look at their face. Gharial, super weird. Tomistoma, very croc, just with a very skinny snout. The DNA disagrees with that almost entirely, that the two gharials should be grouped together, very close together, and in fact, probably in a group together, and that they both are close-ish to crocodiles, not in crocodiles. So the gharial gets brought further in, and Tomistoma comes out and is grouped with it.
And they meet halfway.
Yes.
In that regard, so we talked in our episode 194 was alligators and caimans, that alligators and caimans are closely related to each other, and then this would put crocodiles and gharials as basically the other half of the family tree.
Yes.
Versus the idea that it's alligators and caimans, crocodiles, including the false gharial, and then Indian gharials off there doing their own thing outside of everybody.
As a third major branch.
Yeah.
Here it seems, that gharials are still their own group together, so kind of like alligators and caimans, but a little bit more separated from the crocodilids, but still on that side of the crocodilian group. This split in the data has been frustratingly consistent for a very long time. For huge history of the research, bones and fossils said one thing, DNA said the other, and never between shall the two ever meet seemed to be the case for a long time, decades. This also brought up an issue because the two data sets also would mean very different evolutionary timings for gharials. Molecular evidence suggests that Tomistoma and gharial should have split around 30 to 18 million years ago.
Okay.
Fairly recent-ish.
Early Miocene-ish.
Yes. While fossil evidence suggests, if we're going off of the fossil gavialids that we have, the earliest members are late Cretaceous, which is quite a step back. 80 million years old versus 30-ish million years old.
Right, that's 4 times older.
Yeah. So we run into this issue of not only is it disagreeing on where they should be, but which one's right really shifts the evolutionary history of not just this group, but crocodilians.
Yeah.
So it's been a major focus of study, people trying to figure out why. What's the issue? Why are we getting such a mixed signal? Many people looked at this and thought, surely there has to be a signal in one of them that we're missing. Something we're not seeing that will agree with the other, because they can't both be true. One of these has to be the one, or at least more true. You know, there might be a third option that we're not seeing. most looked for a secondary signal in the morphological data because DNA is real hard to just disregard. That is what makes the animal what it is. So it's very persuasive in that regard. Different studies using different sets of data have been able to find morphological signals that, when added into research, does agree with the molecular tree and timing, molecular tree for these groups. There have also been attempted to do combined morphological and molecular, both the body and the DNA together in the same data set, and typically those recover the molecular result.
Okay.
And fairly recently, a study was able to, just using morphological data and no input from the DNA, reproduce the tree we get from molecular information purely on physical traits.
Okay. So there is evidence within the anatomy that does agree with the DNA. So it's not an
Yes.
insurmountable gap.
Absolutely. There's also a number of reasons to, be cautious about morphological data versus molecular. Molecular data has been tested over and over again using different parts of the genome, mitochondrial DNA, RNA. They have tested this with every bit of DNA that you can think of, and every single time it comes out with the same answer. While the morphological is muddled a bit more by convergent evolution potentially, but also, while they have refined the traits that they've looked at for analysis, many traits are often reused. So if that trait is the thing muddling the signal, it's getting used in more data and in more studies. So the morphological is more likely to be where the issue is.
Mm-hmm.
Doesn't mean DNA is perfect. It can still have convergent evolution within genes, and our closest living relatives to do genetic comparison with for crocodilians are birds, and that's really not a very close relative. So
yes,
there are reasons, as one paper put it, prudent to be considerate of issues with the DNA, but all of these criticisms that come up with DNA have been addressed in studies, like, specifically, and still come out to the same answer. So now it's kind of hard to not take the molecular answer. These days, most things you'll see group the two gharials together close to crocodilids, and that is the modern understanding thus far.
Sure. And thank goodness, because that is the more convenient answer.
Yes.
Convenience should never be the reason that we favor one hypothesis over the other, but I am satisfied that the answer does seem to be gators and caimans on one side, crocodiles and gharials on the other, and we call it a day.
Yep.
Because otherwise you have to explain that the false gharial is in fact not a gharial, and actually it's a crocodile, and what's a gharial? Who's it related to? Nobody. It's off doing its own thing. That's a much more confusing situation. As a science communicator, I am in favor of the DNA results.
Absolutely agree. And it would be tied up with a nice bow if not for that. This still does not fix the timing issue. The DNA, if we go with it, suggests that they should have split 20 to 30 million years ago, and we've still got fossils that are 80 million years old.
That look like gharials.
And when studies have been done, consistently group out with gharials. So this is the issue. This early group, known as the thoracosaurs, are the problem currently, and there's been research looking into how sure are we that they're gharials, and if some aren't, if some are misidentified, that might fix some of the timing issue.
Yeah. As a science communicator, I'm in favor of just tossing them out.
Get out of here,
Thoracosaurs who? You're really messing up the narrative here.
For that, we'll talk a bit more about these early gharials and gharial evolution after a short break, so stay tuned. Our earliest gharial-looking crocodilians show up in the late Cretaceous to early Paleogene and are known from Europe, North America, and Africa. Now, as we mentioned in the last part, a contingent of these are often known as the Thracosaurs. Now, this is not an official taxonomy, so this is not an actual group, but it is what these early stem gavialids are often called. These are often found in marine and coastal deposits. Our oldest Thracosaur is about 72 million years old for sure, which also makes it about as old as the earliest members of crown crocodilia. So the modern groups of crocodilians. This is about as far back as our first members start showing up, which suggests a very early divergence of the Gavialis lineage of Gharials and their cousins. There is a species, Thracosaurus. It's the only Thracosaur known from North America. And this is why that timing is so difficult. We have a fairly consistent fossil record from the end-ish of the Cretaceous to today of gavialoids. We even have members of the Temistamine line going back at least to the Eocene, about 54 million years old. So we have fossil members of this group going back way farther than the DNA suggests they should have split. This could be because these Thracosaurs aren't gharials and are in fact another group of crocodilians that just convergently evolved the gharial shape, something that has happened many times. We'll talk about that later.
Yes, this is the most intuitive solution, is to just say, yeah, they're not gharials. Crocs love to look the same, and then we can throw them out like I suggested.
Absolutely. And that would at least help the timing issue. It might not fix it completely, because I do think there are some pretty resolute gharials that are in between that 80 to 30 million years, but it would help. But most studies still find Thracosaurs as gavialids, and that's the issue. There are some that have found them outside. I found a recent one that found evidence, and they concluded they should be considered a stem crocodilian group outside of gavialoids and therefore not considered. But that one's still messy. We don't know for sure. So most things that you find, if you look up what is the fossil history of gavialids and gavialoids, it will take you back to at least nearly the Cretaceous. So it's that we still don't know. We don't know exactly when gharials split from each other or other crocodilians based off of the DNA and fossils. So those still aren't agreeing completely, even though we now agree they should be together. Going off of the fossils we have, if we take all of them as gharials, their fossil record seems to have gotten its start in Africa, coastal Africa, and then they spread to the Americas and Asia.
Okay.
And based off of the fossils, it seems in that order that they came from Africa to the Americas and then to Eurasia, which is now where they are both found.
Yeah.
This spread happened fairly early because some of our earliest non-Thracosaur gharials, gavialoids, are things like Moroccosuchus from Morocco and Kentisuchus from Europe, which are late Paleocene to early Eocene. So they got around pretty quick. We have evidence of gavialoids in the West Indies during the Oligocene, and gavialoids are known from South America from late Oligocene to early Miocene. So based on the current fossil record we have, and the fact that Gavialis, our modern gharial, seems to be more closely related to South American gharials than African taxa, suggests that our modern gharial ancestry came from the neotropics here in the Americas. So that means gharials probably started in Africa, crossed over the Atlantic to the Americas, mainly South America, but they did make it into North America some as well, and then crossed over, whether through coastlines or more transatlantic crossings, to Eurasia, and then ending up in West India. Most of this fossil record between the Americas and Eurasia are of a single group, a clade called the Gripposuchinines. And many of these are found, like throughout their fossil record, are found in coastal and marine habitats.
Yeah. Whereas modern gharials, as you were saying before, like most crocodilians today, are freshwater and variably with some tolerance for coastal or brackish habitats. But
Exactly.
crocodilians tend not to be ocean dwelling animals.
Yeah, there's a reason that the saltwater crocodile got its name, because though all crocodiles can drink salt water because they have
Hmm.
salt glands in their tongue, there's only two today that really make regular use of that by going out into ocean water, and that's the Australian saltwater crocodile and the American crocodile, which is sometimes known as the American saltwater crocodile.
Hmm.
Modern gharials, both Indian and false, are strictly freshwater. They both still have those lingual salt glands, but they're reduced in the Indian gharial, likely because of their freshwater habitat habits.
Hmm.
But fossil record wise, it seems that they had well functioning, and many species were, if not coastal, sometimes marine, maybe actually
Yeah.
swimming out in open water. So the crossing of those transatlantic crossings likely were not, oops, a random animal got washed out of a river during a storm and happened to make it across, but swimming or island hopping and making it from one continent to another.
Yeah, which is very cool to know because this is another one of those cases where intuitively this makes a lot of sense.
Mhm.
Because, like you were saying before, gharials today are arguably the most aquatic, or at the very least, the least terrestrial
Yes.
of our modern crocs. If any one of them was going to go full out into the ocean, these are the ones that you would imagine, at least anatomically, are suited to do it.
Precisely. So our fossil gharials were in much wider amount of habitats and spread more out around the world than they are today. And the hotspot for gharials was actually South America.
Yeah.
Yep. Famously known for caimans, it also had a number of species of gharial. We see them arrive in the neotropics first in the Caribbean and then making their way into the proto Amazon. So before the Amazon existed, the area where it would be was where we found them. And then they were part of the assemblage of the mega wetlands, the Pebis
Hmm.
mega wetlands that are famously known from South America during the Miocene, which was basically just a super swamp, massive and perfect to have so many different types of crocs, mostly caimans, and a few gharials among them, which are notable because they were the only ones shaped like gharials. All the caimans
Yeah.
had typically very broad, strong, crushing bites and snouts, and then the only slender snout crocs in that habitat were gharials.
It's a very cool combo because caimans and gharials do not overlap even close today.
Nope.
These are you will outside of some sort of very strange intervention, you will never see a caiman and a gharial in the same place. They just do not live in the same part of the world. The idea that they were the two big croc groups in South America for a while is very cool.
Absolutely. So yeah, South America had a diversity of gharials, both in species but also in size. There were smaller species that only got to be 5, 6, 7 feet long, and large species, which we'll talk about more in just a bit. But there were some big gharials. They were also found throughout basically every habitat, every aquatic habitat you could find in the area: coastal, marine, estuarian, rivers. Everywhere they could fit, you had a gharial living there.
Yeah, every body of water big enough for a gharial to be in it.
Yes. These, once again, were from a group called Grippasukines, famous for this genus Grippasuchus, which had multiple species. These also made it to Eurasia. So we have Grippasuchus species there as well. So this is the group that really did the spreading in the neotropics and Eurasia. They were super diverse during the middle Miocene, during the time of these wetlands, and then we see them start to decline toward the end of the Miocene. This syncs up with a couple of different events. One, the wetland starts to dry up and give way to more fluvial plains. So Still aquatic habitats, but not this super wetland that was so perfect. And we do also note that it coincides with the arrival of crocodilus to South America.
Mm.
So the environment's changing, the Andes are uplifting and it's shifting the whole environment down in South America. It's a famous event that happened and changed a whole bunch of stuff during this time. But also crocodilus arrived. There are crocodile species in South America along with the caimans. We have the Orinoco crocodile, which is the main one, and we also have things like the Mexican crocodile and the American crocodile. The Orinoco crocodile, and to a lesser degree, the American, both are fairly slender snouted crocodiles. Not
Yeah.
nearly as ridiculous as a gharial, but compared to something like a Nile croc, pretty slim snouts. So there has been thinking that maybe crocodiles arrived to South America with snout shapes that could compete with gharials, and that was part of the reason. Now, not all research agrees on that. There's been research. I found a paper that blatantly said we don't agree with that at all. Looking at today's slender snout crocs and gharials, they don't seem to have the same ecological niche. So we don't think that they would be directly competing. But were that true of the fossil gharials? It's harder to say. It's definitely a thing to take note of. Whether they pushed them out or took their place when they left is harder to know.
Yeah, and it could be, speculating on my part, that those great wetlands were a perfect habitat to be a gharial shaped crocodilian. But then as those wavered, it became a little harder to get by as a gharial, and a slender snouted crocodile was better suited to this new form of habitat. So it might be that the gharials disappeared partly because they lost habitat, but then what habitat remained for them was now being occupied by these other crocs.
Yes. Either way, between about 6 million to maybe as recently as 1.5 million years ago, gharials had left the Americas. They were no longer here. That dating is based off of the youngest current fossil known from this
Mhm.
area, a species of Pisco gavialis. That's at least in that 6 to 4 million year range, maybe more recent. And then we were left with the Eurasian populations. We do have fossil records of Gavialis in that area of the world. We have at least 3 species, the modern, 2 others that we have fossils of, and they range from India, where they're currently found, all the way to Pakistan, and at least one other member in Java, which suggests that they likely dispersed from the Indo-Pakistan region to Indonesia throughout their dispersal.
Mhm.
And in this case, it does seem like dispersal by sea was less likely, and that they are most likely going through drainage areas and river basins as they dispersed,
Yeah.
which brings us more or less to the modern day.
So once again, this is another recurring theme when you look at distribution through the fossil record. We just missed them
Yep.
here in the Americas. Like it also means that assuming that the slightly older ages are correct for when they vanished from South America, they also just missed the Great American Biotic Interchange.
Yeah.
So South American gharials just barely avoided having bears and elephants and big cats and stuff.
Just what a shame. Just so many cool paleo arts that could have been done of that mixture.
Yeah, the world we live in is an unusually gavial free world.
Yeah.
That like our variety of crocodilians today are much more anatomically consistent
Mm-hmm.
than a lot of time periods in the last 80 million years or so where you had much more variation in, especially when the case of gharials, snout shape.
Yes. So like very similar to like elephants and stuff where we used to have like an elephant per continent, at least. We had gharials on almost all major continents. Like there's no reports of Australian or Antarctic gharials, but every other continent we got a
Yeah.
gharial at least.
And they were abundant. In South
Yes.
America, like you said, there were many different species, many different shapes and sizes. Whereas today we have two,
Two.
which, if I remember your description from earlier, correct me if I'm wrong, don't overlap.
Nope. Nope.
So any given habitat has at most one gharial species, and more likely less than that.
Yes, exactly. And in those areas, you're lucky if you find them because they are not
Yeah.
common anymore. So yeah, we had a diversity. They did though look fairly consistently Gharialish. Like
Mm.
all had long slender snouts. We didn't have any short snouted or wide snouted Gharials, at least not to any extreme. There was variation, but you didn't have anything that had like an alligator face or something
Right.
truly unusual like the
They look
big
like
pelican
gharials.
crocs. Yes, exactly. They all had long slender snouts with pointed teeth. They did have diversity though, and it's similar to our diversity today. You had a distinction between gharials in different habitats that would show in certain features of the skull, but mainly the orbits. Other fossil gharials also had the telescoped orbits that the Indian gharial has,
Huh.
and those were pretty consistently found in riverine ecosystems, river and freshwater habitats, while the
Huh.
untelescoped gharials, gavialids, were found often in more coastal and marine habitats.
What's the benefit of having bulging eyes?
We don't know. Likely it's something to do with their vision, but we don't know what it's doing specifically.
Yeah, because, crocs and gators very famously have the eyes elevated up on the top of the head.
Mm-hmm.
And that is a surface dwelling adaptation. That allows
Yes.
them to linger just below the surface of the water and peek their eyes and nostrils up out of it. But this is an underwater. My first thought, and my only, once again, I'm speculating, is that rivers tend to be hard to see in.
Yes. Yep.
In the way that a lot like freshwater, especially flowing freshwater, can end up being a lot murkier than coastal or ocean waters. So maybe it's helping them see through the gloom in some way. Maybe it's helping with visual acuity.
The only other thought I had is that from river to coastal, you're going from a relatively shallow to a potentially much deeper. The ocean gets deeper than any river we have. That's just kind of the math. Which means if you're hunting fish in a river, you might be able to do that near the surface a lot of the time. So maybe having telescoped eyes allows them to keep their eyes on what's going on above the surface, but have their mouth open, waiting for a fish below the surface. Which I did see at least one description of one feeding in some similar way of being able to hunt underwater, but with the top of the face still above the water.
Yeah.
But in a coastal setting, you're probably going to have to be more diving after prey more actively because they have no reason to come up to the top of the water at the coast.
Yeah, there's not much reason to keep an eye out above the surface because you're in the ocean.
Exactly. So that's the one thought I had. I didn't see that described specifically, but likely that it does have something to do with the visual needs in a river system. This seems to be a fairly consistent pattern. Now, it's obviously not perfect because our modern ones today are both freshwater and live in very similar habitats. So it's not a guarantee, but fossil record wise, it does seem to usually happen that way. And an interesting note, we have Gryposuchus species that have telescoped eyes, but a fairly recent fossil found of a specific species during the middle Miocene of Gryposuchus doesn't have telescoped eyes, which suggests that that is the ancestral state, and that the telescoped eyes we see in Gryposuchus and Gavialis evolved convergently. Even though they were both already gharial shaped, they got the pop out eyes because they were both living in rivers, and that was helpful.
Which just reinforces that this is some beneficial thing to have if you're living in rivers.
Absolutely.
Now, my immediate thought is, what about other animals that do both? What about turtles? Do river turtles have bulgy eyes? What about dolphins? The river dolphins don't see very well. But like, what else is there that we can look at and compare?
Yeah, well, and I don't know of any other croc group. Like, I didn't see it mentioned
Yeah.
any other crocodilian group. This seems to be a Gavialid thing, period.
Maybe this is what happens when you squeeze the snout.
Hell, it has to go somewhere.
The eyes, yes. the eyes bulge out.
Their crocodilian stress toy. It makes as much sense as anything else so far. Another bit of variation that we see in the fossil Gharials, the fossil Gavialoids, is size.
Yeah.
Today's species are fairly similar in size as, upper sized crocodilians. They're somewhere between a gator and a saltwater crocodile on the size scale. Pretty good. We had small species back in the day, but we also had real big ones. Some of the biggest crocodilians that ever lived were Gharials.
Yeah.
Some of the top ones to mention: Piscogavialis, which is a marine gavialid known from the Miopliocene of Peru. There's 2 species that are known. One, which is, like 14 feet long, so not quite 4.5 meters. Pretty decent.
Mm-hmm.
I didn't find an exact size estimate for the other, but the description was the other species is nearly double that.
That's a lot of Gharial. So that's like a 25-foot
yes,
Gharial.
At least.
which does outsize any living crocodilian species.
Yep. And it also represents this genus some of the best preserved Gavialid fossils. The holotype skull is 3D preserved,
Cool.
Which is very nice. There's also a genus of Tomistoma lusitanica, which is also from the Miocene and is estimated at somewhere around 8 meters, so 26 feet long.
Oof.
Yep. Which, this one is from Eurasia, would make it one of the largest Western Eurasian reptiles after the dinosaurs.
Yeah. That is a thing to keep in mind when we're talking about Cenozoic crocs. Past the Mesozoic, we're now talking about the largest reptiles on the planet.
Yep. Oh, it's so good. The next one, which is my personal favorite, is a Gryposuchus species, Gryposuchus croizati. These, as mentioned, this genus is one of the more common ones. They were found all over and they ranged in size. This species has been estimated of getting up to 10 meters, so 33 feet long, which would probably be a croc that's almost 2 tons.
Mm-hmm.
Now, estimates based on different parts of the body will give you different estimates. This is the more conservative one because based off of the length of the skull, evidently this would give you an estimate that's like 3 times the size.
Which is too big.
Which is ridiculous.
That's too big. Also, basing the full body length off of the length of the skull for a Gharial is pretty... That's not the part you want to use.
Exactly.
The part that they're just
disproportionately long
that's
face.
That's like trying to estimate a person's height by the length of their hair. It's like, no, that's not... That's not... You don't get to use hair for that.
This was not the only giant Gryposuchus. There's another species, Columbianus, which is estimated at like 8 meters again, like 26 feet long. And then finally, often considered likely the largest Gharial and one of the largest crocs that ever lived, Ramphosuchus. This is an Indian Gharial. 2 species, both big. One from the Oligocene and Miocene of Pakistan, estimated between 6 to 8 meters, so 20 to 26 feet long. The other from the Pliocene of northern India, estimated between 8 to 11 meters, so 26 to 36 feet long. These also were more robust than your typical Gharial.
They'd have to be.
Not just, but their snout is more thickly built and likely meant that they could be a bit more of a generalist and may have been taking larger prey. They also have a depression around the nares, around the nostrils, which means they might have also had agara, which just How big was that thing?
Yeah, that was my thought. Did you just have a what did your pop sound like? You just be walking along the Miocene of India and just do, Vroom!
Clayton.
Just like just like mines going off under the rivers.
Yep.
That's so cool. It's just fascinating to think, because like crocs are so big.
Yep.
But I have gotten to see up close and personal pretty big crocs. Like I've been fairly close to like a good sized alligator. Right? And that's a big animal. A good sized alligator is double my full body length.
Yep.
A 30-foot gharial. How big was your head?
Yeah. I got to stand near a 17-foot saltwater crocodile once, and I stared at that thing for 30 minutes just in awe of how massive it was. I can't even imagine. That's just 30-foot croc.
Just a croc you could crawl inside.
Yeah.
But at the same time, these are gharials, which means if our modern species are anything to go off of, you probably wouldn't have had to worry too much about them. Like, as long as you left them alone, you were probably fine. I can't imagine that these were human hunters. Even Temistoma today isn't going after people all that much.
Though we will talk about that, because that's been the classic interpretation, that if you're shaped like a gharial, you must be eating fish.
Right.
But there's more to be said. Before we get into that, because that deals with something known as the longirostrine problem, which is the fact that there are lots of crocs that are shaped kind of or a lot like gharials that are definitely not gharials.
Yeah, once again, in our modern world, gharials are very unique. And so it's easy for us to go, oh yeah, you're either a gharial or not. But
yes,
in the fossil record, that is not the case.
And even today, we have some other slender snouted crocs. Famously, the slender snout crocodile of Africa, genus Mesetops, is very thin snouted. Now, one of the things that distinguishes a lot of our slender snouted crocs and the gharials is when you look at their lower jaw. The lower jaw is made out of two sets of bones, and us just, fused bones, but with crocodilians, it's still separate. But they're made out of a left and a right set of bones, your left and right mandible. And in most crocs, those form a U or V shaped, but they are separate. They are only fused at the chin. With Temistoma and gharial, they are fused down most of the length, and they form a much more Y, like the letter Y shaped structure.
Yes. If you put your finger underneath your mouth, like underneath your chin, you can just sort of poke your finger up between your jawbones into your mouth. Don't do it too hard because you will hurt yourself. But there's no bone blocking you there. You could go right up through there. Most crocs and gators, you can do that same thing all the way to the chin. Gharials, you could only do it down close to the throat.
Exactly. And this actually is another distinction between them and other crocodilians. That soft spot between the jawbones is where the crocodilian gular pouch, the pouch that they have in their mouth that allows them to carry their babies. So if you ever watch the alligator carry its babies from the nest to the water, it relaxes the floor of its mouth and creates this mouth pouch. Gharials can't do that because they don't have the ability to make a mouth pouch, and they don't carry their babies.
Gharials, bad parents.
They watch them after they get to the water, but the babies have to get there on their own.
All right.
So they're much more of a teach you how to swim by throwing you in the pool kind of parent.
Bootstraps. Get on out there. What do you want? I've made a nest for you.
But then once they're in the water, they're actually good parents. There's some of the most famous pictures, if you look up crocodilians and babies, will be a gharial covered by its babies with them all over the back of the female.
I have seen those. I was just trying to think. I was like, have I ever seen a gharial with babies in its mouth? No, but I've seen them covered in babies like a possum.
Yeah. So they guard the young once they make it to the water, but they just are unable to carry the young to the water because they would just have to bite each one.
Yes. Also, they've got all those teeth, just like rows of sharp, pointy
Oh,
teeth.
it's just a stretch of barbed wire for a mouth.
Yes. Like, as famous as crocs and gators are for their mouths, it's pretty easy to put your hand in an alligator's mouth without actually hurting yourself on the teeth, as long as the gator itself is not trying to hurt you in that moment, because
Yeah.
the teeth aren't like touch them and you get, it's not like a cat's claws.
Yeah, exactly. These are not needle sharp.
No, you're not going to easily accidentally hurt yourself on a crocodile's teeth. But gharials do have very needle-like teeth.
Those are very sharp. Today's crocodilians, we have the slender snout croc. We also have the freshwater crocodile of Australia, has a very slim snout. And the Orinoco crocodile also has a very slender snout. Sometimes the American crocodile will get included in this list, but those get mentioned most often as our slender snouted crocs of today. They range from 3 categories of slenderness that you'll see used sometimes: narrow, which is going to include things like the American crocodile, the Orinoco crocodile, and the freshwater croc, which don't have any fusion of the lower jaw and have a wide base to the snout. Narrow semi-tubular is getting up to things like Tomistoma and the slender snout croc, where the base is still wide, but most of the snout is narrow. So while in the narrow snout, it gradually, continuously narrows. So it's still a V. Here, it narrows quickly and then is mostly consistently narrow the rest of the length. And there's a little bit of longer connection in the lower jaw. And then tubular, which is just the Indian gharial, has crazy fusion of the lower jaw and very consistently wide snout, with the widest bit usually being, once you get past the base of the snout, the tip where it widens back out, and evenly sized teeth. Tomistoma has very sharp teeth like the Indian gharial, but does still have some cananiform, some enlarged teeth in the length of the jaw, while the largest teeth on a gharial are actually at the tip, where they have their largest teeth for grabbing at the tip. Every other tooth is basically exactly the same size, going back to the last one near the joint. This feature and shapes like it have been found throughout the fossil record of crocodilians. It's thought that this is a trade-off adaptation, that while it is not good for necessarily crushing or strong bites, or at least facilitating strong bites, it increases speed both in opening and closing of the mouth and reduces hydrodynamic drag in the water, which is why it's often been thought to be such a good tool for catching fish. Smaller cross section means you can sweep that through the water faster than, say, an alligator could.
And we do see similar shapes in a lot of other aquatic animals. It's pretty common, for example, for fish to have that same sort of narrow, long snout.
Absolutely. Ichthyosaurs have a very thin, narrow snout. River dolphins, which is another reason why the connection to rivers and stuff has been so strong for gharials, are very gharial shaped. Some notable croc groups from the past: there's a group called the Tethasuchia, which have a lot of members that are very gharial shaped. Most famously, there's 2 groups, the Dryosaurids and the Phyllitosaurids. Both have gharial shaped members. Phyllitosaurids are the more famous because they include Sarcosuchus.
Oh, hey, that's a famous one.
Yep. So these are outside of our modern crocodilian groups, but they are closely related. Sarcosuchus, Imperator, the emperor crocodile, is famously one of the absolute biggest. Estimates going up into that 9.5 meters, so 31 feet long. Some estimates are more conservative at like 29 feet long, which means compared to some of the other gharial estimates, some of those might be longer than Sarcosuchus.
Yeah.
Which is just to give that perspective that some of the less famous ones are also Sarcosuchus sized.
Yeah. I did have the pleasure of standing next to a replica Sarcosuchus skull some number of months ago. And first of all, it's very fun to see a skull and go, I know who that is.
Yep.
I just know that skull off the top of my head. Also, they're so big. That is so big. It was surrounded by other skulls it could have swallowed.
Yep.
Oh, like it was next to like a rhino skull or something. And it was like, you could just eat that. You could just eat that rhino skull. It's
Yeah, their
so big.
skulls are like not quite 2 meters long, but like
Yeah.
their skull's like 5 foot and change. And it's insane. They do have at least relatively thin snouts. It's still a very
Yes.
wide snout compared to like my palms. And
Mhm.
like if I was trying to hold this snout, but compared to the face and body, a long, slender snout also has the largest teeth at the front and an
Mhm.
expanded nostrils. No evidence of a Gara that doesn't have the same impressions, but it does have an expanded nasal opening and slightly telescoped eyes.
Oh, I didn't know that
Mhm.
about Sarcosuchus.
So very Gharial-ish in a lot of ways.
Fascinating.
There's also another phyllitosaur, which is Chalawan thailandicus, related to Sarcosuchus. That's estimated at about 10 meters, 33 feet long. This one's from late Jurassic to early Cretaceous. Sarcosuchus is also Cretaceous. In Africa, this one's from Thailand, as the name suggests. There's also other groups that we've talked about previously, like the Thalattosaucians, the marine crocs,
Mhm.
which were full of slender snouted members, many very, very Gharial shaped. And if you look them up, they will just say Gharial shaped
Yep.
because some of them are so similar. My favorite non Gharial shaped croc, just because it's got a fun name and weird snout, is Euthecodon. This is a genus within the Osteolaemin crocodilian group, so the same group that includes the dwarf crocodiles and slender snout crocs, known from Africa fairly recently during the Neogene, and has very long snouts. Like when you see pictures and skulls of them and reconstructions, cartoonishly long, very Gharial proportioned. Gets narrow, stays narrow the whole way, but where each tooth is, the snout bulbs out.
Oh,
So you end
right.
up with this saw shaped outline if you're looking at them from above. It's scalloped, is the way I've seen it described. And you get this wavy outer margin of the snout, with each
Yeah.
tooth being in one of the bulges out. It's super weird looking and so cool.
So strange. That's really taking it. That's having your cake and eating it too. We're going to keep things as slender as possible, but also we want big honking teeth.
Yeah, and like the tooth sockets are also unusual in these. Like that help to stabilize the tooth, it seems, because they have very thin, sharp teeth. They've also had estimates that put them up in those upper size ranges for some species. One specimen was estimated between 7 to 8.5 meters, so 24 to 28 feet long. Other estimates have put up around 10 meters, 33 feet again. These estimates, once again, are based off of different proportions, and not all proportions might be as accurate. So it could be that we're getting an exaggeration based off of their very weird skull. But it was not a small croc, even if it was smaller than these measurements.
Yeah.
And they have raised eyes, but not telescoped orbits. So their eye sockets aren't poking out, but the entire orbit region is more elevated.
Yeah.
So they do seem to have some similar adaptation going on with the eyes, just in a different way. This fun selection of crocs and others, like this is not all of them. There are like individual members in certain groups that have shown similar trends, just aren't a group of Gharial shaped crocs, led to what is famously known among croc researchers as the longirostrine problem. And this is a problem mainly within taxonomy, that similar shaped animals, when you put them through an analysis, and in the fossil record, we can't use DNA, so we have to use the shape of these animals. Similar shaped animals will tend to clump together because, based off, when you're giving me the shape of the fossils to work with, I'm going to tell you these two are the same picture. I can't find any differences. So it means that there's been a lot of confusion as to where exactly these groups go. The marine crocs have bounced around whether or not they're in Neosuchia, which is the group that contains our true crocodiles, or not. The issue with Temistoma and Gharial stems from this longirostrine problem. So there's been a number of studies trying to sort this out and trying to be aware of and note where we can more accurately group these long snouted crocs. Based off of our current understanding of the taxonomy, long-snouted groups evolved twice with the Tethasuchia and the Gavialoids. Used to be thought it was 3 times back when Tomistoma and Gavialis were separate. But if they share an ancestor, then it seems like we have 2 main groups that evolved it, and then individual evolutions that are slender snout members of a non-slender snout group.
Yeah.
There's at least 3 of those that often get mentioned. Euthecodon, slender snout, and the freshwater croc often get grouped. A lot of studies don't include some of the other crocodiles like Orinoco and American, but depending on how picky you're being, you could have more. We tend to see similar skulled features show up. Some of the ones we mentioned about the lower mandible. Also, the fact that the maxilla, the upper bone that bears teeth, will often meet in the middle, and the nasals get pushed backwards, which is the nasal bone is usually the back of the nostril opening. With a lot of these species, they don't actually touch the nostrils. So the nasal bone does not touch the nasal opening because they've been squished out of the way by the maxilla, the tooth-bearing bones. Another thing that this Longirostrine problem has brought up is there have been a lot of assumptions about what a snout like this means for an animal, and those are not always as consistent as they seem. The most famous one is that if you look at any fossil animal with a long, slender snout, it will almost instantly be said, this is a fish-eating snout, much like today's modern gharial. That is a very common statement because today's gharial is almost exclusively a fish eater and has this long snout, which makes sense to be good at catching things in the water. I don't want a big paddle-shaped face. I want a thin spear to be moving through the water.
Yes. Also, many same-sized pointy teeth is also a very common feature of fish-eating animals. You see that in mammals. You see that in other fish. Lots of animals are like that.
Good for holding on to slippery prey. The sharp teeth also help with other features of the slender snout, meaning that you can pierce your prey more easily. This has been a very popular and consistent comparison, but is it actually accurate? Our 2 species today both mainly eat fish, but that's also true of basically all crocodilians.
Yeah.
Like alligators, bulk of their diet's fish. They eat other stuff more frequently than a gharial or Tomistoma would, but there's like saltwater crocodile, it's mostly going to be fish. Most often, they're going to be catching a fish. So most crocodilians eat fish, and they all hunt for fish very often in the same way, which is mouth open underwater and then swiping the head left or right. That's the same way we see them all hunt.
Yes.
Gharials are probably going to be better at it, so it makes sense that it might be an adaptation to specialize in that way, but it is not required to eat fish. So looking at a slender snout fossil animal and going, that's what you were doing, is potentially missing part of the narrative, since that is not required to eat fish. It's not like having digging claws. You need to have a way to dig if you're going to be digging. You don't need a gharial snout to hunt fish. So, that's one assumption that kind of seems like it gets made.
A gharial-shaped snout probably makes you good at catching fish. Yes. But it does not necessarily mean that you are exclusively or even predominantly a fish-eating animal.
Yes, and it's this weird contradiction because we see in today's species, Tomistoma actually eats a wide variety of animals. Other birds, reptiles, small mammals, up to fairly large mammals. The gharial is mostly a fish eater. It'll take things like frogs potentially, but there have been instances observing adults scavenging larger prey animals that aren't fish. So the ability to eat larger prey is not necessarily off the table. It's just not what they are known to do.
Yeah, that snout shape, not only do you not require that snout shape to be a fish eater, that snout shape also does not limit an animal to eating fish.
Yes. So it's this weird thing of, we do have evidence of our gharial-shaped crocs not being fish eaters, but if you are going to be a fish specialist, you probably would want a gharial-shaped snout. Yes. So, it's not broken logic, but assuming that if it's shaped like a gharial, that's what it was mainly eating, may be missing some information. This is further muddied when we look at other features. bite force. So crocodilians famously have very powerful bites. The
Mhm.
most intense bite measured in a living animal today is from saltwater crocodiles.
Yeah. Crocs, their general strategy is they only want to bite once.
Yeah. Yep.
The best jaw is one you only have to chomp
Yeah.
once.
it's the way Dinosuchus did it. And it's worked pretty well so far. This often has been looked at when it comes to snout shapes, as you have snouts that are really good for strong bites and snouts that are less good for strong bites. A thick, robust snout like a Nile croc, a gator, or like caimans, which are shorter and wider by comparison, are good for making strong bites, while slender snouts, longer snouts are going to be bad for making strong bites. Research that actually went and collected bite force from every single crocodilian found out that's not the pattern.
Hmm.
The indicator of how strong a croc's bite is going to be is how big is the croc. And that's it.
Mm.
With one exception, big crocs give big bite force, small crocs give lower bite force, regardless of snout shape.
Interesting.
And it depends, same position of the snout. If you put it at near the joint, Tomistoma slender snout crocs produced the same level of bite force as an alligator or a saltwater crocodile.
Okay.
If they are the same size, so
Right.
they can't get up to the same bite force as salties because salties get bigger. But
Right.
that's the only determining. The only exception is the Indian gharial, which does produce weaker bite force. So it could be that the Indian gharial is the exception that proves the rule. It is a fish specialist. Tomistoma has a bite force as strong as an alligator.
Right. It might be that the Indian gharials' weaker bite force isn't because they have a slender snout, it's because they're eating fish.
Yes, exactly. So this could mean that, some gharial shaped slender snout animals may have followed this trend. We do see evidence in at least one Thalattosuchian that was compared to Gharials that seemed to also have a very weak bite force based on their shared anatomies. But something like Tomistoma is able to produce strong bites. Now, the slender snout can't handle those strong bites as well as a robust snout. It's going to be put under more stress. So they probably can't utilize that bite force as effectively. But
Right.
they do have the ability to produce it, which means for like at the back of the mouth, they can put some real pressure on something. In a similar line, death rolling. So famously, death roll is the tactic used by crocs to dismember a large prey animal by biting and twisting a piece of meat off that's small enough for them to swallow. It's also used to get away. If they're grabbed, they'll often death roll to try to spin out of the grip or the bite of another animal, or like the ropes that are being used to try to capture them.
Mm-hmm.
A study went through to see which species do and don't death roll in feeding and in escape situations. Every single species except for the dwarf caiman, if I remember right, death rolled in at least one of the situations. Tomistoma death rolled both while feeding and escaping.
Okay.
So it death rolled to dismember prey and while escaping, which the thought would be a slender snout croc wouldn't have any need to death roll because you're not going to be eating anything that's too big to swallow because you're eating fish.
Right.
But if you have the ability to death roll, then you have the ability to dismember something bigger than a fish.
Yep.
The gharial death roll to escape, but evidently I don't think they did not test whether it would death roll by feeding. And I think, if I remember right, that was because they were afraid of hurting the snout. Gharials
Sure.
are famous for having delicate snouts.
Yes.
But they death rolled to escape, so they have the instinct to death roll.
Interesting. If I remember correctly, this study was Stephanie Drumheller and colleagues, wasn't it?
Yes,
Who
yes.
we met. So those of you who came to our Knoxville Museum meetup got to meet Stephanie.
It's very cool study.
I remember seeing, because this was a poster at SVP some number of years ago, and I remember most of the poster was just a family tree of every species of croc with a check or an X next to it as to does it death roll in both situations, and it was very cool. It was a very eye-catching poster.
Yep, there were some that didn't death roll to feed, but did death roll to escape.
Mm-hmm.
If they death rolled to feed, they did both. And then only
Yeah.
the one species, which I believe, if I remember right, was the dwarf caiman, didn't do either. Does that mean you just didn't want to or can't? Hard to say.
Right. It didn't do it for the purposes of this study.
Yes, indeed. Now, this also is not guaranteed that this is indicative of slender snout feeding, because death rolling may ancestrally be more for escape. And if that was the original reason it evolved, then it might not have anything to do with what they can and can't dismember,
Mm-hmm.
but they have that behavior. So that doesn't seem to have diminished in either of our slender snouted gharials today.
Yeah.
And when we take a look back at Tomistoma lusitanica, the 26-footer that we mentioned earlier, we have evidence of bite marks from this Tomistoma species on bones of large mammals that it shared the fossil sites with.
Well,
Things including gomphotheres and pigs that show not just tooth marks on bone, but crushing of the bones.
yeah. So not just grabbing,
Yeah,
but chomping.
doing some major work on these bones. Now, whether or not it hunted these bones or whether or not it scavenged these bones doesn't really matter, because it meant it was processing large
Yes.
mammals. And once again, we see that with today's Tomistoma. They'll take monkeys, they'll take pig, they've been known to take deer, and there is a documented case of feeding on human.
Mm-hmm.
One paper suggested that maybe today's Tomistoma is mostly fish eating, not by choice, but because of human pressure.
Yep.
That us infiltrating into their habitat and reducing it and competing with it for other prey has forced it to be mainly a fish eater, and maybe they're not getting as big as they would normally. Now, this is based off of basically one point of evidence, but
Okay.
there is a skull at the Natural History Museum in London that is the longest crocodilian skull of any modern species, and it is a Tomistoma skull.
Huh.
The biggest skull we know of a modern species comes from a specimen of Tomistoma, which, based off of estimates, could come from an individual pushing 6 to 7 meters. So now this could be a one-off giant individual,
Mm-hmm.
but it might suggest that our modern Tomistoma could be getting bigger if it had the chance. And maybe if
Yeah.
we did see more large-sized Tomistoma, we might start seeing feeding habits more similar to its ancient giant cousins.
Interesting.
Yes.
Oh, that's fascinating. It is very much it's a polar bear situation.
Yes.
Right, we talked about this in episode 217. Polar bears are very famously hyper carnivorous bears. They are
Mhm.
the most meat eating of modern bears, but they also live in a habitat where there aren't any plants. So they're meat eaters by necessity.
Exactly.
Have we pushed Tomistoma into habitats and situations where they would love to eat more things, but
Mhm.
most of what they have access to is fish?
Yes, and they're not getting big enough, either due to not thriving as much as they could,
Mm-hmm.
or direct competition with humans of being hunted or killed.
Yeah.
All of this goes together to be my soapbox of a long, slender snout is great for catching fish, but that does not mean they were only catching fish. So the next time you
Yes.
see something about, like, look at Spinosaurus's face, obviously the only thing this thing could do. Now, we know they did eat fish, but I still wouldn't want to get near a Spinosaurus's face, because I'm probably fish shaped enough for
There
those
were-
jaws to handle.
There were some big fish during the Cretaceous.
Yes.
Yep.
That's the other thing that always gets me, when they'll look at a snout and go, this thing was only eating fish. So, okay, but if it was eating like an Aeropyma, like,
Right. Or even like catfish.
yeah, like giant catfish, I weigh as much as a giant catfish. So,
Yeah. There are big fish.
yes, anything smaller than that big fish probably also could have been on the menu for that croc or whatever slender snouted animal you're looking at.
Yes.
I saw a post on Reddit once of a just massive male gharial, and it was just pictures of it being released, and then, they got drone shots, and it was just beautiful images. And I was just looking at that size, with a head that has to be pushing, 2 feet long, that snout is no longer skinny. It's still slender compared to the body, but that snout's like as big as my forearm around.
Mm-hmm.
And someone in the comments was like, could this eat me? Like, I know it probably wouldn't, but could it? And I went in to be like, yeah, absolutely. It
Yeah,
probably
of course.
could kill you and eat you if it wanted to. It probably won't because they are famously pretty benign crocodilians.
Mm-hmm.
But yeah, that Gharial's like 3 times the length of the average human.
Yes.
So like,
yeah, if we locked you in a room with it,
yeah,
well, yeah,
exactly.
eventually it's gonna get hungry.
So like, absolutely, a slender snout's a great tool to catch fish. And if you are a fish specialist, you're probably going to end up being shaped like a gharial.
Yes.
But being shaped like a gharial doesn't mean you're only eating sushi.
Yes.
They are not as limited as a lot of, and like, these studies are not doing a poor job, but just this perception is very deeply ingrained and a very go-to comparison. And it gets made sometimes in cases where one paper made the point where we actually have evidence to the contrary, that they were eating more than fish, but they still get described as fish specialists because we get so fixated on the gharial.
Well, and it's also another one of those situations where our point of comparison is a very restricted sample of modern. Well, this is the same thing that has come up when we talk about, we'll talk about giant animals of the past, and it's often very tempting to compare them to elephants and say, oh, well, yeah, these dinosaurs were elephant sized. Can we draw inferences that they may have lived like elephants? Well, there's only like 2 or 3 species of elephants today.
Yep.
That's a very limited sample of animal to draw your basis of comparison on. Gharials live in one part of the world. They have very small populations. They're critically endangered, which means they aren't living their best life. They're not living in a fully undisturbed way.
Yes.
This is a very biased example for us to be using for comparison. Once again, it'd be like comparing ancient carnivores to polar bears.
Yes, exactly.
Yeah, but that's an unusual case, that living animal. We have a lot of data, which makes it very tempting to use that data. But we do have to be aware of the limitations of our comparison.
Yes, and it also seems like the Indian gharial may be a very specialized, potentially weird gharial. Like, other gharials probably were like it, but it is likely not indicative of the full fossil record of gharials.
Yes.
My favorite anecdotal story I ever heard about the comparison between the two was a handler. Worked at zoos handling crocodilians and had worked with Indian gharials and was very used to them. And we're talking about how you had to be very careful because, when you go in an enclosure with a croc, you go in with a stick.
Right.
That if you put that between you and the crocodilian, that usually is enough for them to just go and stop coming toward you. It just gives you something to put between you and them. You don't need like a full shield, and it's just like a broomstick. But he said with the gharials, you had to be very careful because if they like got spooked and swung their jaw and hit the stick, they might hurt themselves because the stick is actually a little bit more robust than their thin snout.
Yes.
Then he got a new job at a new place that had false gharials. So he got to work with Tomistoma, and he said he went in with the same mentality of like, all right, another gharial. I'm going to be careful with the stick. And that, he got too close to one and it decided to like show its mouth at him and, swing its head toward him to ward him off and snapped the stick. And he said he's never moved faster or vaulted the wall of the enclosure faster, realizing that he had miscalculated treating this crocodilian like another.
Yes.
Not all gharials are made the same.
Whew. One of my takeaways from this later part of the discussion is that what we need to do is Future is Wild style. Everybody leaves the planet for, I don't know, give it a few decades, and then we come back to see 25-foot false gharials.
Yeah, like, and that's the other thing that gets me, like, the gharial today is one of the largest like, it's third to, like, saltwater and Nile crocs for size and weight. And it's super specialized, long, thin snout, weak bite. And then we've got, like, 5 other Sarcosuchus, Deinosuchus sized fossil crocodilians that are gharial shaped or gharials themselves.
Yep.
Why were these getting? We only have one caiman that got giant sized. Why are gharials so good at this?
You can get real big eating fish,
Yeah.
which is the other thing about fish. It's like, yeah,
Yeah.
but fish are an excellent food source.
It's real good.
They're a fan. If you're going to specialize in something, fish is a phenomenal choice. They're everywhere. They're nutritious, and some of them are real big. Some of the biggest animals in Earth history have been fish eaters.
Yep. Yeah. Oh, I love this group so much.
Gharials are very cool. They are a very I think that Gharials really drive home the variability of Crocs.
Yes.
Because we think about Crocs as being so homogenous, right?
Mm-hmm.
Yes, technically here are the differences between an alligator and a crocodile, but it's a croc. It's shaped a certain way, it lives a certain way. Broadly speaking, you feel like you can make all the same generalizations about these animals, and that leads to this mentality that then gets applied to fossil crocodilians and fossil croc shaped animals. Gharials are a croc that, by their very nature, force you to realize that that's not true.
Yes.
Just a basic discussion of Gharials and how they function and what they do forces you to recognize that crocs vary. So even today, there is such variability in these animals, in their size, in their shape, in their lifestyle and habitat. And I think Gharials are really the one that draws that conversation out.
Yes. No, they are notably, in multiple ways, the most divergent members. And it makes them just so cool. Also, they're just so cute.
They're
like
so
a
cute.
baby Gharial with just toothpicks coming out of the front of its face is just adorable.
In a group full of famously charismatic animals, Gharials are maybe the most charismatic crocs.
Yeah.
They're just so distinctive because they look goofy in a very charming way.
Yes. Yep. Ugh. Love them. Well, that will wrap up our discussion of the weirdest crocodilians that we have today. But before we go, we have one last section, which is our patron question. Every episode, we like to answer one of the questions submitted to us by one of our patrons, which is a benefit you can get if you sign up with us on Patreon. What's our question for this episode?
This episode's question comes from Steve, who asks not about crocs, but about some other really cool animals that Will likes.
Yep.
How do animals like cuttlefish change color to match the environment and hide?
Excellent question. And yes, another of my favorite groups, cephalopods, cuttlefish, octopus, squid, and the nautilus, but those first three groups have the ability to change their color using cells called chromatophores. And they use this for communication, but famously, especially for cuttlefish and octopus, to camouflage and blend in with their environment. And this is not some simple color change like we see in chameleons, where it shades and just like shifting from one color to another. This is a very complex, very detailed color change, and is situation to situation. You know, an octopus matches its background. These chromatophores are little sacks of pigment. So they're a little bag full of color. Specifically, they come in black, brown, orange, red, or yellow. And they have muscle attachments that can stretch the sac out. And so when they're small, you don't really see the color on the skin. When they're stretched out, it makes the color evident. And by doing that, they change the overall pattern of the skin. They also have other cells called iridophores and lucidophores. Iridophores can create iridescent colors, greens, blues, silvers, and golds. And then luciphores can be mirrors to actually reflect, and this can help like blending in with open water and being like shimmery like a fish sort of thing. That's a system which lets them change color. The ability to match the color around them is much more of a mystery, because as far as we can tell, it's the information's coming in through the eyes of their ecosystem around them, and then they're matching color. But cephalopods have only a single photoreceptor gene, which means they are effectively completely colorblind.
Yep.
So we don't know how they're matching the colors of their ecosystem. There's been like suggestions as to how it might be happening, that their pupil might filter color so that it kind of spreads the wavelengths of color out in the light and gives them some information about the color they're seeing. There's also been like genetic suggestions that might do it, or that seawater filters light anyway. So they're dealing with less wavelengths to begin with. So it may just not be as much of an issue as we're thinking. But we don't know. We don't know how they match the colors, like how they're able to know what color to turn into.
Yeah. They generally are they're making colors they can't see.
Nope. Yep. Exactly.
They also are able to match the color of the background,
Mm-hmm.
which is not where the eyes are.
Yeah.
That's the well, like you'll see, and you know, it's not 100%. It's not like it turns translucent and you can just see through it. But an octopus will like settle on a bit of coral and then become the color of the coral that it can't see right now.
Yeah. Yep. And it's like, did you just make a note of it as you were approaching it?
Yeah.
Are you saying, oh, I know what color the coral I'm on is on? Because you're an octopus, so you probably remember what different color, what corals are
Right.
like.
Absolutely. Well, yeah, and I don't put it past an octopus to go, that's pink, I'm going to sit on it and then turn pink.
Yes.
Sure. Yeah, that makes sense. Do you just have a go-to coral color?
Yeah, exactly. Yep.
How, yeah, they, and of course, you know, I said that they're reproducing colors that they can't see, which is technically true, but also that's true of us. Like
Mm-hmm.
we release light signatures that we can't see. So it might, like you said, it might not actually be that big a deal. They
Yes.
might be reproducing enough variation to fool the animals in the ocean.
Exactly. Yes. I did find one other layer while looking into this that makes it even more impressive. New chromatophores, when they're, quote unquote, made or born, are always yellow. And
Huh.
then through development over like days or weeks, they change from yellow to orange and then to brown. So they move through the spectrum of colors that the chromatophores can produce,
Oh, that's
which
cool.
means that each chromatophore is at a different stage of development and is changing to a new color. So not only are they able to accurately match color that they can't see, they're doing it with a layout of cells whose pigment capabilities are constantly shifting. The
Huh.
area of chromatophore, like this specific
Yeah.
chromatophore that was brown yesterday died and is now yellow today. So they're still also able to somehow keep track of all of that.
Wow. I wonder how quick the turnover is, and can a baby octopus only turn yellow?
I do think they have more, because I think it probably in the egg they start to develop, but I
Yeah.
have
That's my
seen
assumption.
videos of them and their chromatophores are just going woo, 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 woo. And it very much feels like the videos of a baby elephant that's just swinging its trunk around because it doesn't know how to use this
Yes.
complex
Well,
appendage.
I'm thinking of Randall in Monsters Inc. at the end when they're punching him and he's just changing into all the different colors.
Yeah.
Yeah, it's out of control.
Yeah, baby octopus and then like cuttlefish, they're just just flashing their colors and it's very cute.
Adorable. Incredible. Thank you, Steve, for that fascinating patron question.
Absolutely. If any of you are interested in asking your own patron questions, check out the Patreon. Links down in the description. Also, check out the blog post. You can see pictures of all the Gharials that are alive today.
We're going to put every species in that blog post.
From multiple angles.
Yes, I was thinking about, I was like, what pictures are we? Might just be like glamour shots of Indian Gharials.
You'll also be able to find links to other information. And if you want to go talk about Gharials more, the Croc chat is open on the Discord. So you can go geek out about Gharials and other slender snout crocs there, because that's what I'll be doing.
If you enjoyed this episode discussion, this is overlapped with a bunch of other. We did marine crocs in episode 168. We did alligators and caimans in episode 194, our other Croc Month episodes. And it is a great time to listen to those because this episode is releasing in Croc Month.
Yeah, it is.
We're celebrating Croc Month all through June. Like Will said, the Croc Chat channel is open on the Discord. By the time this episode comes out, you will be able to go rewatch our Croc Month live stream, which will be archived on our YouTube. Also, our Croc Month bonus episode, where we talk about some croc research with our special guest, Maddie, is available. Go listen to that. And you can join the Patreon this month at the Crocs and Snakes tier, where your subscription will contribute to charitable donations we will be making towards wildlife conservation. It's an exciting time here at Common Descent.
Always a ton of fun. So join us for all of that. Thanks to all of our new patrons, and thanks to me for requesting this episode, finally.
It was a good idea. I'm glad that you submitted through the proper channels. Did you did okay. I was about to ask, and then I realized I know the answer to it. You didn't actually submit it through the topic request form. You just put it straight onto the request form, but that would have been very funny. In hindsight,
I didn't even think of it. I should have.
Yes, if you had done that, and then I would have had to put it on the request list. Listeners,
oh man, missed opportunity.
You do have to submit your request through the topic request form because you, unfortunately, do not have direct access to the requests list document.
You're not able to cook the books like I did.
You're not able to cook the books, and you won't be, because that would be chaos. we just open it up one day, and the whole thing would be turtles. It would just be the Turtle Month contingent would have gotten a hold of it, and just the entire 1,500 requests for turtles.
Turtles all the time, every time.
Turtles all the way down.
And then we just have to become a podcast just the turtle species of the fortnight, and we just work our way through.
And then it's just and then the logo is replaced. There's a turtle sitting at the desk. And it's just the podcast has been completely overhauled. Listen, when it's time to end the podcast, that's what we'll the last episode we'll turn it over to our turtle overlords.
Oh, that'll be perfect.
Turtle podcast.
Turtlecast. Once we're old, we can do it, and the episodes will be just as long, even though there's less to say, because we'll be talking as slow as a turtle.
Yes. Half the content, same great length.
And finally, a tip-top thank you to our top-tier patrons, Sarah May, Danielle the Bug Lover, and Jeff Ellington. And that's it. Surprisingly, that's I about all I got to say for Slender Snout Crocs, which is I've snuck that topic into a bunch of other episodes.
Yes. This is it, the magnum opus.
I finally got to just everything I want to say about these. Here it is. Ugh, a weight off my chest.
We release episodes every fortnight, and a fortnight from now, it will no longer be Croc Month, and we will be talking instead about snakes for Snake Month.
Long and slender in a very different way.
Long and slender in a very different way. That episode will be longer.
And they never get pointed at and going, obviously a fish eater right there. Obviously, see, it is not a fair comparison. It's really
what people should be doing is pointing at Gharials and going, obviously venomous.
They
better watch out. It's going to get you. It's a constrictor. Let's just wrap that snout around you.
I did see, and I couldn't find this again, so I didn't put it in the main part, but I remember seeing a discussion of Gharials hunting and using their long body and tail against the shoreline to net fish into the shallows.
To pen them in.
Yeah, and then as they try to escape, snapping them up as they move past the mouth. But I couldn't find where I read about that, so I couldn't confirm. But it's a picture that's been in my head, and always that's my favorite image of a gharial hunting.
All right, let's leave.
Bye, everybody.
Thanks for listening to the Common Descent podcast. You can follow us on Facebook, Twitter, YouTube, and check our WordPress blog for pictures and links after each episode. Huge thanks to our patrons whose support helps keep this podcast running and who get access to bonus goodies on Patreon. The song you're hearing is called On the Origin of Species by Protodome, which we found at ocremix.org. Thanks again for listening. We hope you'll join us next time.